Hello my dears, welcome to today's presentation on derivation concept of minimum deviation refractive index. So here what do you mean by prism? As we know, prism is a three-dimensional solid which consists of two parallel identical polygons connected to a flat surface. This is about prism. It is a 3D solid body which consists of two identical parallel polygons connected to a flat surface. So here when we expose light onto the prism, as we know, the light will enter into this medium. This means glass prism. So this is about rarer media, this is about denser media. When light enter rarer media to denser media, when light travel from rarer media to denser media, so actual path of the light ray is, this is the actual path of the light ray as we know. But here whenever the light enter into a prism, because of the changing media, the speed of light ray is changing. Because of that particular reason the light undergo refraction, which is nothing but bending of light, and from the surface of the prism it is emitting out. This we call as emergent ray. We call it is emergent ray, and this is about incident ray. So if you consider a normal, the incident ray make an angle with the normal, that is called as incident angle. If you consider normal one more here, the emergent ray made an angle with the normal, that is called angle of emergent. Incident angle, emergent angle. Let's see here what is meant by deviation. For example, as we discuss here, this is the light propagation. If there is no medium, this light will follow this particular straight direction. Is it right? But when we placing a prism, because of the changing the medium, this light, it is bending and undergo refraction. So if you extended this incident ray, if we extended this emergent ray, both are connected at a particular point, and that is called minimum deviation. This angle is called angle of minimum deviation. Angle of minimum deviation. That means what? Incident ray when we extended, emergent ray when we are extended, backward this one, this is forward. When we extended these two rays, they met a particular point. That angle we called as minimum deviation angle. So this minimum deviation, how it is related to angle of prism, that is our concept now. Okay, that is this is the prism. This is the incident ray. This incident ray during the whenever changing from rarer to denser, whenever it enters from rarer media to denser media, the light is undergoing bending, and this is called as refraction. So it is undergoing refraction, then emitting out. This is called emergent ray. This is the incident ray. Angle made by emergent ray with the normal, angle of emergent. Angle made by the incident ray with the normal is called angle of incident. Now let us consider, we extended a normal ray, from both ends, where the light, incident light striking, and that we called PQ. And where the incident light is at the emergent point, it is considered as R. This is entering point, this is leaving point. This is A. Now this is angle of incident, angle of emergent, angle of refraction, angle of refraction. So from this particular, now let me observe this particular A, Q, O, R, they look like quadrilateral shape. They look like quadrilateral shape. Clear? Now let's see here. Let we have deviation angle, that means minimum deviation. The deviation angle we are considered from this particular diagram. See, overall what is angle? Angle is I, incident angle. This angle and this angle both are equal. Now here the refraction we consider R1. So total angle is how much? I. So I, this area is I minus R1. Here to here the total value is how much? E. But here we taken R2 and this rest of the value is how much? E minus R2. These two are known as internal angles. What we call internal angles. In simple way we consider total deviation is the sum of the bending at both the boundaries. That means the boundary at beginning. At entry level, this bending is at deviation at boundary, entry boundary, that is I minus R1. Deviation at exist means exist boundary, that is E minus R2. So total deviation from triangle TQR, from triangle TQR, exterior angle delta equal to sum of interior angle, that is E minus R1 plus I minus R1, E minus R2. These two are interior angles where this delta symbol, this deviation is about the exterior angle. From triangle we consider sum of exterior angle is equal to sum of interior angle, so that minimum deviation delta equal to I minus E R1 plus E minus R2. So from that we consider deviation, that is deviation delta equal to I minus R1 plus E minus R2, so that we can consider I plus E minus R1 plus R2. At minimum deviation we can consider R1 is equal to condition R1 equal to R2 and R2 equal to R, so that minimum deviation equal to I plus E minus 2R. What is that? 2R, and this simply we can consider as angle of A. So therefore delta equal to I plus E minus A. This is in terms of angle of prism. Minimum deviation in terms of angle of prism. Okay, then we go with the coordinate system. From here we can consider one more way. This is the AQOR. So from this particular condition, let us consider the interior angles. How much? That is about the 360 degrees. So how much? About 360. I will draw one second, don't worry. So this is the prism. Light is incident at normal. Here also it is undergoing refraction, emerging out. Here also one normal. We both the rays are extended. Normal ray 1, normal ray 2 are both are extended. So this is the incident ray, made angle with normal, that is N1. This is a refracted and emerging out, made angle with N2. Now both the rays we extended, they connected here, that is O. Now A, this point is Q, this point is R. So that we can consider. Don't look at that one, look this diagram. That's better for you. You can easily understand. Okay. So this is Q point, this is R point, normal is N1, here the normal is N2, both are connected here O. Now let us consider AQOR. What is that? AQOR. According to this quadrilateral triangle, that is angle A plus angle Q plus angle OCR plus angle R will be equal to 360 degrees. They will be equal to 360 degrees. So that angle A as it is, angle A plus angle Q plus angle OC, sorry, so what is that? AOR, sorry, QOCR. What we have? No, QCR, AQOR triangle, AQOR triangle, sorry, QOR. From this one, it is almost, sorry, not, it is 360 degrees. So angle A you keep like that only. Angle Q is how much? Just now we discussed normal 90 degrees. Angle QOR you keep like that only. Angle R is how much? That is 90 degrees, which is equal to 360. Finally, angle QOR equal to 180 minus A. 180 minus A. So angle QOR equal to 180 minus A. So that is quadrilateral system AQOR. Quadrilateral system is what? From quadrilateral system AQOR we got QOR equal to 180 minus A. Then what is QOR? From that we will consider here. So from the geometry part of, okay, again once again I will draw. So this is the triangle we consider. Oh, wait a minute, sorry. So so light is incident, refracted, emerging out. This point, this is normal ray. So this is Q point incident, this is R point. Now this QOR from triangle QOR, from triangle QOR, angle of Q plus angle of R plus angle of QOR equal to 180 degrees. As we know, the angle made at Q is how much? That is R1. Angle made at R is what? That is R2. Then, sorry, the angle made at Q is R1. Angle made at R is R2. So R1 plus R2 plus QOR equal to 180. Therefore, R1 plus R2 equal to QOR 180. Then what is Q? After reshuffling the data, you will get angle QOR equal to, angle QOR equal to how much? 1. R1 plus R2, angle QOR equal to 180. From previous concept that we simply understood, QOR equal to what? 180 minus A. Just now before we saw in the quadrilateral system we found that one, angle QOR equal to 180 minus A. Replace here, then you will get R1 plus R2 plus QOR equal to 180. After replacing the given data with the substituted value, then R1 plus R2 plus 180 minus A equal to 180. Therefore, our R1 plus R2, 180 180 will be cancelled, which is equal to A. This is A equal to. Okay, clear? Then, as per the symmetry concept, at minimum deviation, angle of I equal to angle of E, angle of R1 equal to R2, and both are equal to R. So that is I equal to E, R1 equal to R2, R2 equal to R. So that we will consider R1 plus R2 equal to A, but from the symmetric concept, because of at minimum deviation, R1 plus is R, R2 plus is R, so that R1 plus R, which is 2R, which is equal to R. And finally, R equal to A by 2. From minimum deviation concept, delta I plus E minus R1 plus R2. After replacing that, delta I equal to what you will get? That is delta minimum equal to I equal to del minimum plus A by 2. So we got R, we got I. So that according to Snell's law, mu equal to sine I by sine R. Replace the data, then you will get, after simplification, mu equal to sine delta minimum plus A by 2 by sine A by 2. This is about minimum deviation value. What is that? Minimum deviation equation. If the prism is very small or thin, then in the place of mu equal sine I by sine R, we should consider just mu equal to I by R. Mu equal to I by R. Okay, now the concept is how delta minimum it is related to refractive index. For that, let us consider delta minimum equal to, what is delta minimum equal to? Previously we saw I plus E minus R1 plus R2. What is I at minimum deviation? I equal to E. So that I plus I, that will be I plus I, which is nothing but 2I. Why? Because I equal to E. Similarly, R1 equal to R2, R2 equal to R, so that R1 plus R, which is nothing, R1 plus R2, which is R plus R, which is nothing but 2R. So delta minimum equal to 2I minus 2R. Then what is I? Just now for very small prism we got I equal to mu R. Replace the things, delta minimum equal to 2R of mu minus 1. Therefore 2R is nothing but what? A. So finally, in terms of the refractive index, angle of prism, that is delta minimum equal to A of mu minus 1. So general prism and small prism comparison. See, general prism depends on full trigonometry, but here small prism or thin prism depends on the extreme geometric character. That means in the place of sine I, we will consider only I. In the place of sine R, we consider only R. This is for the geometry purpose. For the small prisms, general prisms, what we are using laboratory, they are using full trigonometry concept. Refractive index formula for the for the laboratory prism, we are using this one. Here we are using I by R for the thin prism. So this is, and minimum deviation formula here for this one is I plus E minus R1 plus R2. Here in terms of angle, we will consider that is about A of mu minus 1. Thank you. So what just I will recall to you. So first we found the relation what is refractive index. Refractive index nothing but it is a ratio between C by V. Refractive index formula from this concept mu equal to C by means what? Speed of light in vacuum to speed of light in medium. From this concept mu equal to A sine mu equal to sine of A plus dm by 2 sine A by 2. This is refractive index. Then minimum deviation formula delta minimum equal to I plus E minus R1 plus R2. At condition minimum deviation R1 equal to R2, R2 equal to R. So that I plus E minus 2R. But this 2R is equal to A, so that I plus E minus A. This is all about the minimum deviation. Then minimum deviation in terms of the refractive index of A and A. So this is the formula. Minimum deviation in terms of A and refractive index. Okay. Let's once again I will go with the same way. First I consider this prism. Light is incident here, striking this surface A, B, C. This is incident surface and this is about refracted surface. Here it is a normal it is refraction, then emerging out here also one of the normal. So this is Q and this is R. So here it is O. First quadrilateral system. Let's consider quadrilateral system. From the quadrilateral system, okay, this is the light ray of extension. This is light ray of the emergent ray. Both are connected, and this is called minimum deviation. This point is T. Now let us consider minimum deviation. What is minimum deviation? We should use TQR formula from triangle TQR. What is that? Sum of exterior angle equal to sum of interior. What is exterior angle? Delta. Interior is what? Here is R1, here it is R2, here I minus R1, here E minus R2. So that so this is Q, this is R. If you are extended this one, if you are extended this, these are connected. This is about the at T point. This is about minimum deviation. Now this is the normal ray. This is the normal ray 2. Here it is angle R1. Here it is angle 2. Here the angle internal angle is how much? This is about I minus R1. Here E minus R2. Now delta minimum equal to sum of exterior angle equal to sum of interior, that is I minus R1 plus E minus R2. So that I plus E minus of R1 plus R2. This is about delta minimum. Okay, once again you can check that one, no problem. Thank you.